that we're presenting here try to solve a very specific problem. And what I'd like to present is a methodology and solution to leverage what we call access switching to overcome issues regarding to HPC monitoring and HPC networks with this method. The company has been around for 15 years, and as I said, we suddenly found ourselves in the middle of solving problems to those companies that were mentioned here, using all those supercomputers and super nodes. Last marketing slide, we are positioned as a layer between the different tools and the different networks, regardless of the network architectures. And what we do is that we provide access to different tools, security tools, monitoring, instrumentation, quality assurance, content security, etc., and the network itself. And why is it relevant for a high-performance computing? So first, there is the infrastructure itself that needs to be monitored. A large scale of hardware, software, systems, and applications, all of them needs to be monitored in order to ensure that those 256 or 256K CPUs, GPUs actually work and perform what they need to do, that the network itself, 10 or now moving into 40 and 100 gig, is actually performing what it's needed. The monitoring system itself is very complicated, simply because the network that operates and connects everything is very complicated, and there's also a need to have a correlation between multiple points of monitoring. So it's not enough to look at a problem from a specific angle or in a specific point in time. There's actually a need now to correlate between those multiple points where monitoring takes place, and also to synchronize between timing, etc. And also there are specific application requirements of the HPC application themselves. So HPC, we see it as a platform that serves multiple needs, and it was very interesting to see those applications here. It doesn't matter it's for chemistry, for jet designs or anything else. The applications themselves are very, very unique in nature and requires different types of monitoring. So just to mention some of the monitoring challenges, one is a lack of tools, especially as organizations are moving for 1 gig, 10 gig, and beyond. There are simply not enough tools. And what we found out that researchers either have to write their own tools, because the tools that they currently have or previously wrote or previously purchased cannot meet their needs, or that the volume of traffic is now so overwhelming that those tools are unable to meet the requirements. And sometimes it's just a cost. Obviously, when you have a $75 million project, you can get a couple of millions for monitoring tools, but how many here actually have such budgets? Okay, maybe on slides, but not in real life. So the cost itself is becoming a limiting factor. There are some additional issues like oversubscription of the switching capabilities, latency and jitter that actually prevents the right results from being calculated and then being presented. So I'm not diving into each one of those issues. If you'd like, I can talk for hours about this, and I'm going to be in the next room after this presentation. And we can chat more about it. But the point is that especially the limiting factors of the network prevent accurate monitoring and prevent accurate presentation of the data that was monitored by you. So basically what I'm trying to suggest as an alternative is to use methods of access switching. Try to perform more with the different tools that I'm sure that you already have in your networks and in your labs. One is to use load balancing, being able to use multiple devices by simply sharing the network load, leverage existing, sometimes cheap tools, and also allow you to plan for growth. So you start with a system that has a specific capability today, and you can use more of that. One note that I wrote to myself when I saw the previous presentation was about being able to maintain some parallelism of computing by using load balancing or load sharing. There is an option actually to try and use similar systems, each one with limited resources, but now the load is effectively being shared upon multiple systems. Pre-filtering of data. Sometimes not all the data is relevant for your tasks. So by using methods that are available, such as DPI, it's possible to pre-filter, look just for specific data that needs to be analyzed and use it. Use different tunneling methods to move data from one place to other places. For example, leverage the cloud and leverage open cloud, where you can have a cheap CPU power, or relatively cheap for purchasing it, and then analyze this data somewhere else, for instance, in your facility, where you actually control the instrumentation and collecting data. And also use other methods to actually monitor inside the cloud and inside the VMs. And this is actually a part of the discussions that I was hoping to hear here today, and I didn't hear anyone talks about leveraging publicly available resources in the cloud to create multiple clusters, etc. At least not in the way that I was expecting it. Maybe in some of the next meetings, something that can be addressed. In regards to specific requirements of HPC applications, one of the most common examples that we see is with the algorithmic trading. And then specifically within algorithmic trading, sometimes called as flash trading. Most of us know it as automatic trading. There's a unique need to have very fast reactions, and since all the decisions, all the trading is being performed by computers, the main limit there is actually the speed of light. And well, we already know that even this is no longer a real limit, but still those traders, they try to overcome the speed of light, even in monitoring. So the way that the infrastructure is built, the way that they design monitoring between traditional switching to switching that use, for instance, non-traditional store and forward methods, really affect what they are capable to do. So I'm not going to talk about specific products in this presentation, but one of the methods that I would like to suggest is actually to think about using non-silicon for even faster monitoring. And when you think about it, every switch layer adds an additional latency to the network, even if the latency is very, very low. And today we start to see products that are publicly available in the area of less than 300 nanoseconds for every packet size with predictable jitter. Even that sometimes it's not fast enough. In that case, I would like to suggest of using components that do not use silicon at all, but would copy the data streams electronically, or actually would not perform the switching itself, simply add it and allow it to analyze it. Regeneration is another method that allows to simply take traffic from a single source and then copy it multiple times when each copy is exactly identical to each and every other stream that entered the system. The use cases in the HPC environment is being able to perform the same task over and over again by playing a specific traffic, or by viewing a specific stream, and then being able to act on this exact data multiple times. So you simply regenerate the traffic, allowing multiple devices to see the same copy over and over again. There's no additional routing that is involved, no additional switching that is involved. Devices themselves do not add any overhead. In fact, they also copies error, and they simply copy traffic as is entered the system. From latency results, you can see here some of the numbers. It's pretty fast if you compare it to traditional switches. Even if you look at some of the newest generation of switches that are available today, it's still 4x faster than anything else. And again, for specific use cases, it's worth at least looking at. So I will stop here. If there is any question, I'll be happy to answer now or later.